Okay, so let's scoot on. Let's talk about graphing, cosecant and the secant functions. So let's look at their parent graphs first, and then the domain and range for each one, okay? So let's talk about cosecant. When I talk about cosecant, what I have to remember is the cosecant is the reciprocal of sine. Agreed? So I should make myself a nice little table to help me out to remember what this is going to be. So we have our typical thetas from our circle. We have 0, we have pi over 2, we have pi, 3 pi over 2, and then we have 2 pi. Agreed? Well, if I take 0 and I plug it in, what's the sine at 0 radians? Yeah, the sine at 0 radians is 0. And if I flip 1 over 0, if I flip that over, yeah, that becomes undefined. Well, already that's not starting out so hot, but okay, here we go. So pi over 2, if I take the sine at pi over 2 radians, good, that's a 1. And 1 over 1 is 1. Remember, cosecant's the reciprocal of sine. Sorry if I remember what sine is. All I got to do is flip that number over, right? Take its reciprocal. At pi, what's the sine at pi? 0. And 1 over 0? Yep, undefined again. How about at 3 pi over 2? What's the sine at 3 pi over 2? Good, -1. And if you flip over, if you take the reciprocal of -1, it's -1. And back to 2 pi, well, 2 pi and 0 are the same. So here's the deal. I've got a lot of undefined stuff going on here, and that's not helping me a whole lot. So I'm going to utilize some other angles. And I'm just going to utilize first quadrant angles. So 30-degree angle is how many radians? Good, pi over 6. 45 degrees, that's pi over 4. And 60 degrees, pi over 3. In a previous lecture, I remember which is which by remembering the 3's and the 6's go together. So if I see a denominator of 6, I know it's a 30-degree angle. If I see a denominator of 3, I know it's a 60-degree angle. With me? Okay, so here's the deal. Let's work out the sine of each one of these, and then when I take the reciprocal, that'll give me cosecant, won't it? Okay, so you get your calculators punching. By the way, make sure your calculator's in the right mode. If you're punching in these radians, you better make sure your calculator's in radian mode. If you're punching them in as degrees instead, 30, 45, 60 degrees, then you better make sure your calculator's in degree mode. So, I've already done it. These are the numbers I got. You verify and make sure you agree. Okay, so for cosecant, I got 2, 1.414, and about 1.15. Okay, so when I plugged in these 3 radian measurements to x, and I took the sine of them and then took the reciprocal, these were my values. Hopefully we agree. So let's take a look at this. Now, there's nothing added or subtracted to this, right? Are you with me? None of that stuff. So I don't have to worry about those characteristics we spoke about in a previous section, because there's nothing tacked on to cosecant, nothing added or multiplied to it, nothing. So I have my typical 4 quadrants, or 4 intervals, starting at 0, pi over 2, pi, 3 pi over 2, and then at 2 pi, right? Okay, so here's what I already know. At 3 places, I already have undefined. It's undefined at 0 radians, it's undefined at pi radians, and it's undefined at 2 pi, which create these asymptotes, my vertical asymptotes. We've spoken about asymptotes before. Okay, and then I know when I plug in pi over 2, I got 1, and I got -1 at 3 pi over 2. So interestingly enough, it leaves me only 2 points separated by 3 asymptotes. I can't even connect the 2 points. This is why I wanted to get these other three angles in here. Because understand, these other three angle measurements are first quadrant. And first quadrant is between 0 and pi over 2. Agreed? So, knowing that is going to help me find the shape of this particular graph, at least in first quadrant. So, pi over 6, right? That was my 30 degrees. 45 degrees was pi over 4, and then pi over 3 was the 60 degrees. So at pi over 6, I got 2. At pi over 4, I got 1.4. And then at pi over 3, I got 1.15. So if I connect just these dots, do you see what's happening? Good. So if I choose angle measurements between 0 and pi over 6, this little area right here, the graph is just going to keep going up, isn't it? And it's not going to cross this asymptote. Good? Okay. Now, put your thinking caps on. Right? When I am in second quadrant, and I'm taking the cosine of these angles, the y values are positive in second quadrant, aren't they? So, when I figure out these angles, the same ones, but in second quadrant, my answers are still going to be positive, aren't they? Good, which means my graph is going to go up on this side. You can plug the numbers in to make certain that you agree. Now, in third quadrant, between pi and 3 pi over 2, my y values are negative, aren't they? And again, you can plug them in to make certain, but here's what's happening in third quadrant. And fourth quadrant, your y's are also negative. Are you with me on this? Okay. Here is your, for at least one rotation of the circle, here is your sine graph. Now, I want to look at its domain, and I want to look at its range. So, the domain of this thing. Yeah, we've got asymptotes in the way, don't we? And the asymptotes are at 0, pi, 2 pi. What do you think the next one would be at? Yeah, the next one would be at 3 pi. And then after that, 4 pi, and then, good, 5 pi. What happens if I go in the negative direction? Good, negative pi. By the way, this is technically a 0 pi, isn't it? So I have 0 pi, 1 pi, 2 pi, 3 pi, negative 1 pi, negative 2 pi, negative. So here's what you're telling me. The domain of this thing is the set of x such that x cannot be equal to n pi. And you're like, what's n? N is an integer. Remember, integers are not fractions and they're not decimals. So, n is an integer. -1, -2, 0, 1, 2. And that's exactly what's happening here. I can't let my x's be equal to these pi's with an integer in front. Cool? Okay, let's look at the range. Now, as we can tell from this part of the graph, this is all going all the way down to negative infinity, isn't it? So I know my range is starting at negative infinity, and it's coming up and it ends at, good, it ends at -1, and it is inclusive because there's a solid dot here. There is a bracket then going around the -1. But there's another part of the range, so union. The other part of the range starts at +1, inclusive because I see a solid dot, and it goes all the way to infinity. Does that make sense? Good. Now, you know, one huge observation here. Cosecant's the reciprocal of sine. Agreed? The graph of sine is the graph of the what? The mountain to the valley, isn't it? Check this out. The mountain to the valley. Here's what this tells me. It tells me that the cosecant graph picks up where the sine graph leaves off. The sine graph is fluctuating between a -1 and a +1. The parent graph is, which means the cosecant graph is going to pick up and not cross over the sine graph. So in this area, it's going to go down. It can't go up because then it interferes with the sine graph. And in this area, it goes up because it can't interfere with the sine graph, so it can't be down. So it has to go up. So think about it. If you knew what the graph of the sine function was, would you be able to find the cosecant function? Yes, you would. Stay tuned. We got to graph secant next. Okay, so let's take a look at graphing secant. Remember, secant is the reciprocal of cosine, right? So let's go to our table and let's look at what happens when we plug in these normal radians from the circle. So 0 radians. What's the cosine at 0 radians? Good, 1. And if you take the reciprocal of 1, you get 1. So that would be secant, right? Pi over 2. I want the secant at pi over 2. Well, if I know the cosine at pi over 2, all I got to do is take its reciprocal. Agreed? What's the cosine at pi over 2? 0. The reciprocal of 0 is, here we go, undefined again. Let's look at pi. If I want the secant at pi, what's the cosecant, or pardon me, what's the cosine at pi? Good, -1. Take its reciprocal, it's -1. So the secant of pi is -1. How about 3 pi over 2? What is the cosine at 3 pi over 2? Yeah, that's 0. Reciprocate it. So the secant at 3 pi over 2 is undefined. And back to 2 pi. 2 pi is the same as 0, so I'm going to get a 1. So here's the deal. One more time, I've got like 3 numbers to work with. That's great. And a bunch of undefineds. Actually 2, but still that's enough. So I'm going to pull in some other first quadrant angles to help me out. So I need to take the cosine at each of these and then take their reciprocals to get secant, don't I? Okay, so I've already punched into my calculator. Again, make sure your calculator's in degree mode if you're punching it in degrees, or radians if you're punching it in radian measurement. So be very careful when you're punching in these angles into your calculator. If your calculator's not in the correct mode, you are going to get a far off answer. Trust me. Okay, so at pi over 6, I got 1.15. At pi over 4, I got 1.414, and then at pi over 3, I got 2. Gee, it almost looks like the exact same numbers from the cosecant graph, except they're in reverse order. Well, it kind of makes sense, right? Because we're talking about a 30-degree angle and a 60-degree angle, and those guys, their cosines and sines are like opposites of each other, so to speak, right? Okay, so let's look at the graph. Let's see what happens. So we have our 4 quadrants, or 4 intervals, still at 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi, right? We know we have asymptotes at pi over 2 and at 3 pi over 2. We know that at 0, we get 1. We know that at pi, we get -1. And then at 2 pi, we get 1 again. So I have 3 dots, which I can't connect because of the asymptotes in between, right? Okay, so now let's take a look at what happens when I looked at these first quadrant angle measurements. So we're talking about cosine, right? And in first quadrant, cosine is, yeah, it's going to be positive. So when I put the pi over 6 and I put these values in, I'm going to get a graph that looks like this, right? Okay. Quadrant 2, your cosine's actually negative, because remember, you're finding cosine and then reciprocating it. It's negative. So my answers in quadrant 2, or the second interval, are going to be negative answers. It's still going to be these three, but they're going to be negative answers, because we're talking the cosine function, which is the, I'll leave it there. And in quadrant 3, cosine is also negative, isn't it? Which is why the graph is going to do this. Same values, but they're going to be negative. You can punch it in your calculator, see if you agree. Okay? And then last but not least, quadrant 4, or this fourth interval, they're still the same answers, but they're all positive. So, that's an interesting looking graph, isn't it? Now, let's find the domain. Notice I have asymptotes at 1 pi over 2, 3 pi over 2. What would the next one be at? Yeah, 5 pi over 2 and then 7 pi over 2. What about in the negatives? Negative pi over 2, negative 3 pi over 2. So here's the deal. In this particular case, it's a set of x such that x can't equal something with a pi over 2 in it, right? But it's n pi over 2. And the n, the numbers in front of these pi's are odd, where n is an odd integer. So your x's can't be equal to these pi over 2's where the coefficient is odd. Got it? Okay. Range. So if I take a look at the range, according to this part of the graph, it starts at negative infinity. And where does it end? Yeah, negative 1. And there's a solid dot there, so there's a bracket. Inclusive, right? Union. Because I have a second part of the graph, and they both here start at positive 1. Inclusive, because there's a solid dot, and they go to infinity. So, for cosecant and secant, the range is exactly the same. It's outside of the positive 1 and negative 1, right? It goes negative infinity to negative 1, and then positive 1 to infinity. The domain is different because the asymptotes are different. Got it? Now, secant was the reciprocal of cosine, wasn't it? What's the graph of cosine? It's a valley. Watch this. See it? There's the valley. And the secant graph picks up where the cosine graph leaves off, just like the cosecant graph picked up where the sine graph left off. Okay, so let's look at graphing this cosecant function. Now, here's the thing. Remember what we said. If we knew what the graph of sine was, because sine's the reciprocal of cosecant, if I know what the graph of the sine function looks like, then I actually can find very easily the graph of the cosecant function, couldn't I? So here's my suggestion. My suggestion is you first graph the sine function, because sine is the reciprocal of cosecant. And you're like, wait, don't any of these numbers flip over since we're talking about the reciprocal? No, they actually don't. Everything remains the same. What happens is I'm actually going to look at the reciprocal of cosecant, which is sine. When I know what this sine graph looks like with the exact same numbers the cosecant graph has, then I know exactly where cosecant is going to pick up. Cool? Okay, so we know how to graph the sine function. What's the first thing you've got to find? That's right, amplitude. What's my amplitude in this case? Good, 1/2. What's the amplitude tell you? Excellent, the range. What will my range be in this case? Good, inclusive, negative 1/2 to positive 1/2. Excellent. And that's right, you have to ask yourself if it flips. Does it flip? No. Excellent. So what's the sine graph look like? Yeah, the mountain to the valley, so it's going to stay the mountain to the valley, right? What's the next thing we identified? Period. And that's going to be 2 pi divided by, that's right, 1/4, which is basically 2 pi times 4, which is 8 pi, isn't it? What do you find after the period? Low e, the length of each interval, and that means you're going to take 8 pi and divide by 4, so the length of each interval is 2 pi, isn't it? Okay. What's after the period? Good, vertical shift. Do I have a vertical shift? Nope, because I don't see any number added over here. So the answer is no. And last but not least, yeah, I've got to see if there's a phase shift. Remember how you find that. The normal circle goes from 0 to 2 pi, correct? In this case, it's not just x, it's 1/4 x minus pi over 2, and I've got to figure out what happens to the 0 and 2 pi when I get x by itself. So, get your algebra on. What's the first thing you have to get rid of? Pi over 2. So I'm going to add pi over 2 to all three sides. Agreed? So the 0 is now pi over 2. What's 2 plus a half? Yeah, 2.5, but we don't write it as 2.5. Good. 5 over 2 pi. So 5 pi over 2. Excellent. And then what do we have to do? Got to get rid of that 4. So everything gets multiplied by 4 now, doesn't it? Okay, so some of us want to see this because why? We're visual people. So it looks like we're going to start at 2 pi, less than or equal to x, less than or equal to, what happens when we cancel? Looks like we get 10 pi. So we do have a phase shift, don't we? My phase shift, we normally start at 0, but now we're starting at 2 pi. So it looks like the phase shift is to the right by 2 pi. Cool? Okay. Let's start this graph. My range is from a negative 1/2 to a positive 1/2. I'm starting at 2 pi now. I don't care about the 0. I'm not going to put 0 in here. I'm going to start at 2 pi. And yes, this is not to scale. And I still have 4 intervals. And I'm supposed to end at 10 pi, aren't I? Okay. By the way, what's the length between 10 pi and 2 pi? 8 pi, which is my period. So yay for that. That checks out. Okay. What's the low e? The low e is 2 pi, isn't it? Length of each interval is 2 pi. So I'm starting at 2 pi. When I add another 2 pi, what do you get? Good, 4 pi. When I take 4 pi and add another 2 pi, 6 pi. I take 6 pi, add another 2 pi, 8 pi, 8 pi, add another 2 pi, you end up at 10 pi, which is exactly where we're supposed to end up at, aren't we? Okay, so now let's look. If I take 2 pi, because this is where I'm starting, right? I'm starting at 2 pi. If I take that and plug it in, 1/4 times 2 pi. Yeah, that's 2 over 4. That's pi over 2. Minus pi over 2 is 0, which is exactly where my first angle should be. My first angle should be me really taking the sine of 0. And we know the sine of 0. What's the sine of 0? 0. Yes. 0 times a half? 0. Remember what we've mentioned before. If we can get the first 2 or 3 of these points, and when we get the first 2 or 3 of these points in place, and we see that they're going where they should go, then the rest of them will fall in place and I don't have to worry about it. Okay. The next number, or the next theta I'm plugging in is 4 pi, isn't it? Okay, so what's 1/4 of 4 pi? Good, that's just pi. 1 pi minus a half pi. Pi over 2, yes. My second angle I should be taking the sine of is pi over 2, because remember the circle. 0, pi over 2. And then pi, 3 pi over 2, back to 2 pi. So my second angle, this 4 pi, takes me right back to pi over 2, which is exactly where it should have taken me. So what's the sine at pi over 2? Good, 1 times a half. Excellent, 1/2. Okay, so right here is supposed to be the graph of my sine function. Are these points lining up? Yes, they are, which means my next point at 6 pi is at 0. At 8 pi is a negative 1/2, and at 10 pi is back at 0. So when I actually connect the dots, I get the sine graph that I know I should have gotten, the mountain to the valley. But was I really supposed to be graphing sine? No, I was supposed to be graphing cosecant. Remember, cosecant picks up where sine leaves off. Do you remember the cosecant graph has asymptotes? Vertical ones, correct? Where do you think your vertical asymptotes are going to be? Good, right at those zeros. So I know at pi over 2 is a vertical asymptote. Because I take the reciprocal as 0, I get undefined. The same at 6 pi. Take the reciprocal of that 0, undefined. Same at 10 pi, right? Okay. So cosecant's picking up where sine's leaving off, which tells me in this case I get an up parabola over here and a down parabola over here between these asymptotes. And when I erase my sine graph, here is what your cosecant graph looks like. Good? So here's the deal about the cosecant graph and even the secant graph. It's an exercise in you knowing how to graph sine and cosine. And all these wonderful characteristics that we've spoken about before are back again. So as long as I know how to graph sine and cosine and get all their characteristics and then put them on the graph, then it's very easy for me to graph either cosecant or secant because it picks up where the other one leaves off. Good? Okay, let's get into tangent.